Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 3D Part 1 assignment. Okay, first one we're going to take a look at here is number 1. Simplify using the rules of, or like power rules here, right? So a to the m times a to the n is simply just add the exponents as so long as the bases are the same. So look, these bases are the same, so this is going to be 11 to the 4 plus a. And you can't really simplify that at all, so we just leave it as 11 to the 4 plus a. Okay, these here bases are the same, so we can add the exponents. 5 to the negative 6 plus 3 gives us 5 to the negative third. All right. Okay, number 2, simplify using a to the m over a to the n, which means you subtract these two exponents, right? So this is going to be m, since the base again is the same. We get m to the 10 minus 4 gives us m to the 6. Okay, another way to look at this, just so you understand, is really this is 10 m's up here. I'll stop it and write this quick. 10 m's on the top and 4 m's on the bottom because they're all multiplied together, right? So really those turn into 1, those turn into 1, those turn into 1, those turn into 1, and we have, guess what? M, we have 6 of those m's left. They're all multiplied together, so that's m to the 6th power. So same thing as that there. All right. This one here, bases are the same, so you simply subtract the exponents. So this is going to be x to the 3a minus 2. Can't simplify that, so we just leave it. Okay. Number 3, simplify using a to the m raised to the n power is you multiply. It means that you multiply the two powers. Okay, power raised to a power. So this is v to the 5 times 5. So that is v to the 25th. Another way to look at this is really this is v to the 5th 5 different times, right? Like so. And if you have all of these multiplied together from our other exponent rules, we would add those all up. 5 plus 5 plus 5 plus 5 plus 5. Guess what is v to the 25th, which is what we just had right there. Okay. This one here, power raised to a power, this is going to be 2 to the 4 times negative 3. So this is going to be 2 to the negative 12th power. All right. Moving on. Number 4, 7 to the 6th over 7 to the n. Just says simplify. Since it's one over the top of the other, we subtract. 7 to the 6th minus n, since the powers are the same. Subtract whatever's on the bottom from whatever's on the top. Okay, same thing here. Z, because they're both z's, so the bases are the same, so we take 7 minus 4t. Can't simplify that, so we just leave it like so. All right. Right, as a power of 2. Okay, I'm going to ignore the 1 over 8. I'm just going to look at the 8 here and say, oh wait, I know that 8 is 2 to the 3rd power. So we can write it like that, but if it wants it to be really a power of 2, we need to move that up here to the top. So it's going to turn, if I ever change something from the bottom, move it up to the top, the exponent changes from positive to negative or negative to positive. It basically just switches signs. So this would be 2 to the negative 3rd. Okay. 1 over 64. That is going to be 1 over 2 to the 6th. I believe 4 to the 2nd power is 4 times 2 is 8 times 2 is 16 times 2 is 32 times 2, yep, that's 6. Okay, so that equals 2 to the negative 6th there. Okay, all right, moving on. Right, is a power of 3, so 1 over 27. I'm just going to just pay attention to 27 right now. I know that 27 is 3 to the 3rd power. So since we're writing it as a power of 3, we got to move that up. So that turns into from 3 to the positive 3rd on the bottom to 3 to the negative 3rd on the top. Okay, 243. Let's see. I'm not exactly sure what that is. So I know that 3 to the 1st is 3. 3 to the 2nd is 9. So keep multiplying. That's 27 times 3 is what, 81, times 3 is 243, so that's to the second, third, fourth. This is 3 to the 5th power. Okay? There, just to make it look a little nicer. And I guess equal signs. Okay. Number 7, write as a single power of 2. 2 to the x plus 1 squared. Okay, so I've got a power raised to a power. So this is going to be 2 to the x plus 1 all times 2. So really this 2 is going to get distributed to both of those pieces. So it's going to be 2 to the 2x plus 2. And that's good. Okay. Now, these bases are not the same, but I know that 4 I can turn into 2 squared to the x over 2 to the 1 minus x. So this up here is going to be, if I've got a power raised to the power, I multiply them. So that's 2 to the 2x over 2 to the 1 minus x. And then I've got one power over the top of the other, so that's going to be 2 to the 2x. I'm going to subtract everything on the bottom. So I'm going to put that in parentheses to make sure I don't mess that up. So that's 1 minus x in parentheses. So this ends up being 2 to the 2x, and then distribute that negative to both of those. That's minus 1 plus x. So then when we simplify, we get 2x plus x is 2 to the 3x. And then we have minus 1. Okay? Okay. Looking at number 8 here, right? As a single power of 3. 27 is 3 to the 3rd times 3 to the d. We know that when these are, the bases are the same and we're multiplying these together, we add the exponent. So it's going to be 3 to the 3. Actually not 3 times d, but the 3 plus d. Okay, add the exponents. Okay, this here we've got 9 and 3. So we're going to have to turn this 9 into 3 squared. And plus 1. 3 to the 2n minus 1. So this 2 is going to distribute to both of those. So that's going to be 3 to the 2n plus 2 over 3. That's not a 3, that's a 2. To 3 to the 2n minus 1. So we take this as 3 to the 2n plus 2, and then we're going to subtract everything on the bottom, which is 2n minus 1. So distribute that negative to both pieces, and we get, running out of room here, so 3 to the 2n plus 2 minus 2n plus 1. So the 2n and the negative 2n cancel each other out, so we just end up with 3 to the 2 plus 1, so that would be 3 to the 3rd. Okay. All right. Number 9, express in exponent form with a prime number base. So 4 is not a prime number. So what we want to do is turn that 4. We can turn the 4 into 2 squared to the 5th. So power raised to a power means you multiply them. So that is 2 to the 10th power. So 4 to the 5th power is the same thing as 2 to the 10th power. Okay. This here, 25 is not a prime number. 5 is, but 25 is not. So we're going to turn 25 into 5 squared to the p power over 5 to the 4th power. This is going to be 5 to the 2p, because the power raised to the power, you multiply them, over 5 to the 4th. And then we take 5 to the 2p, and then we subtract, since the bases are the same, then we subtract these two from each other, 2p minus 4. And you can't simplify that, so we just leave it like that. Okay, last one for the 3D part 1, write without brackets. So really this is m to the 1st, n to the 1st. That, for me, this makes this a lot easier, and then I know I'm just going to multiply both of those by 3, so this is going to turn into m to the 3rd, n to the 3rd. And we are done. Okay. All right. That's all there is for the first part of the 3D assignment. If you have any further questions on this, please feel free to ask in class or out of class. Thanks.